Hey everyone, how's it going? Micah here. I'm one of the creators of Arroyo, a new state-of-the-art stream processing engine that lets you process data in real time just by writing SQL queries. In this tutorial, I'm going to walk you through how to solve a real-world streaming data problem without writing any code using Arroyo and some other open source tools. So let's get to it. What we're going to be doing is building a real-time web analytics service that's able to give you insights into what your users are doing on your website in seconds. So some of you may be familiar with Google Analytics. It's kind of the dominant web analytics service today. They have a real-time mode like this. We can see people who are, in this case, on our homepage. And if I go and refresh here or click around, we should see these requests pop up here. Go check out the About Us page. You can see this dot in the Bay Area, it's me. And in a few seconds, you should see the page requests here as well. So we're basically going to be building a version of this using Arroyo along with a few other open source tools. And I'm going to show you how you can do this with essentially no code aside from some SQL queries we're going to be writing. There we are. So let's get started. So just to kind of walk you through what we're going to be doing today, we're going to be using a variety of open source components along with the Arroyo streaming engine to build a real-time analytics dashboard for our website. Some of those pieces we're going to be using, a little bit of JavaScript to basically collect events as users are navigating around this site. That's going to send an HTTP event to Vector, which is this great kind of Swiss Army knife for connecting all of your different big data systems. That's going to send that event on to Kafka, where we're going to read it from Arroyo. In Arroyo, we're going to write our SQL queries that are going to produce our metrics, and then those will be written back to Kafka, where they'll be ingested into Postgres, where we'll finally be able to query them in Grafana and build some nice graphs. So with that overview, we're going to get started by actually collecting the data from the website. So our website is a Next.js application with dynamic routing, so there's no page views happening here. Now, there would be a lot of ways to collect this data, but for simplicity for this tutorial, we're just going to use a tiny bit of JavaScript that's going to pull in some information from the browser and send it on to our server. So I've already kind of written this up, and I'll share this text later, but essentially you can see we're just, in our Next.js app, we're just pulling in some information from our React router, and then on every change of the path or the search parameters, we're producing this event and sending it on to our server. I mentioned earlier, we're going to be using Vector to actually receive these events. So Vector is this great utility for connecting all of your different systems that produce and consume events or metric data. So here we're going to be using the HTTP server source, which is able to receive events from, for example, our JavaScript snippet here, and the Kafka sink, where we'll be writing our data. So we're going to start by just setting up the source. For part one of this tutorial, we're going to be running everything locally on my laptop. So that's a way, it's really easy to get started building these systems. In part two, we'll talk through how to actually productionize this on Kubernetes in a real deployment. But for now, we're just going to be running this locally, which means that we need a way to get the events from the internet, from our users, to my laptop. For that, we're going to be using a tool called ngrok, which is able to create tunnels from the internet to your local computer. So we'll set up an ngrok tunnel here. It's able to receive HTTP events. We'll start it on some random port, 9845. And then we'll configure this URL in our Next.js app. Great, now requests should be coming from here. I have a local copy of this running, so let's make sure that works. You can see in the browser tools, we should be making a request, and Okay, we get a 502. There's nothing actually listening there yet, so that's expected. And we can see it is coming in here. So now I'm going to push my changes to our actual website. This is hosted in Vercel, by the way, so we just push to a Git repo. And of course, if we're doing this more carefully, we should probably push to a branch first and make sure it all works, but I'm just going to trust that is correct and send it to our actual website. Also, in the background, there's a build process happening, and then it will deploy this new code. In the meantime, we're going to get Vector set up to actually receive these events. We're going to be using Docker to run all of our services, just to keep everything contained and make it easy to make this all reproducible. So we're going to start by kind of creating a directory to keep track of all this stuff. We'll call it real-time analytics. Then we'll open this up in VS Code. And the first thing we're going to do is create a vector.toml file. This is the configuration file for our vector. I'm going to create a source. Let's call it analytics. It's going to be of type HTTP server. It's going to have an address of 0.0.0.0 and this port that we decided on here, 9845. It's going to expect encoding. It's going to expect data in JSON format, and it's going to expect post requests. And for now, we'll just create a single sync that just prints this data to the console so we can see that it's coming in correctly. So send this as JSON. Cool. And now we're going to set up our Docker compose. So version 3 and our services. And we'll start with our first one, which is vector. If we go to the vector website, we can find the Docker image. Here it is. We'll use this image. We'll expose that port that we decided we're using. And then we'll expose our config as a volume. And here, got this. So this is going to mount our config where vector expects it, and then we can just Docker compose up that, and we should be running. And we forgot to specify our inputs here. Okay, now that's running. And now if we go back to our setup here, we should actually see the events flowing into vector. Perfect. There they are. We can see the various things we're collecting here: browser language, version, page, the host. Perfect. Okay, and I think by now things should also be deployed to the real website. So let's go check out the About Us page here and see if that's coming in. And it is. Perfect. Now we're ready to set up Kafka. This is where the events are going to flow so that they can be read by Arroyo. We're going to also use a Docker compose stage for this. For the image, we're going to use the Bitnami Kafka. We'll expose the main Kafka port. And then we're going to have to configure some environment variables. Which I'm just going to copy from here. We're going to be using the KRAF mode for Kafka, which basically means we don't have to run Zookeeper. And then we're also going to run a health check so that we're able to prevent other services from starting up until Kafka is ready. Now we can restart our Docker Compose with the Kafka running. And it looks like that's all starting up. Perfect. And then here we'll also, since we're now relying on Kafka to exist, we'll add a depends on condition for Kafka, so it's healthy. And now Vector will wait to start up until Kafka is ready. Now we can go back into our Vector config, and in addition to our console sync, we'll also create a Kafka sync that is going to write this out to Kafka. It's going to have input from analytics. It's going to be of type Kafka. And we'll call the topic JavaScript events. And we'll set the encoding to JSON. Perfect. Now we can restart all of this and this is not quite right. Kafka. Okay. Now Kafka's starting up, and once it's ready, we should see Vector start up as well. Looks like we have a problem here. Missing Bootstrap servers. Okay, this is Bootstrap servers. Cool. Now this is running. Should see this pop up here. Yep, there it is. And then we can also go log into the Kafka container. So docker exec. And we can use the console consumer to make sure that our events are actually flowing as we expect. Console consumer JavaScript events. And we should see if we now refresh the page. Yep, our events are coming through on Kafka. Perfect. So now we have our events coming from our website via the JavaScript snippet, going to our HTTP server in Vector, and then being written into our Kafka topic. The next step is to start up Arroyo. So we're going to add that to our Docker Compose as well. For the image, we can just go to our home page and get the image here. We're going to expose two ports, 8000 and 8001. And then we should be able to run that. So we can just do docker up, docker compose up. And perfect. Now this is running. And so now we should be able to go to the web UI, localhost 8000. And now we can start creating pipelines. So in Arroyo, there's a few different ways we can connect with sources. We can either go through the web UI and create a Kafka connection like this, or we can create it directly in SQL. And I'm going to do that for now, just because it's a little bit easier to share that. So we're going to start by creating our table. And this has to, this is going to decode the JSON. So we're going to give the schema of the events. For that, it's easier to kind of actually look at the events. So we'll copy this here. And I'm going to just going to use JQ to format this, so it's a little bit easier to look at. I'm just going to have this here as a reference. Then we're basically going to be describing all these fields in SQL. So we have browser, which is text. We have browser language, which is text. Host, path. For screen height, which is an int. Screen width, which is an int. Apparently I was not consistent about my underscore versus camel case. Source type, which is text. Time, which is an int. Timestamp, which I think is the thing that Vector is adding. Actually, I think title is a text, and URL, which is text. So now that we have this, we can get rid of that. Because we're trying to read from Kafka, we have to also tell Arroyo how to connect to Kafka, and that this is a Kafka table. Oh, we have to give this a name as well. Let's analytic events. We're going to tell Arroyo this is a Kafka connection. We're going to tell it that the format of the data is JSON, that it's a source, the Bootstrap server, so how to connect to Kafka. And for those of you who aren't familiar, Kafka Connect by default makes all of the containers available to other containers within the same configuration using their container name. So we called that Kafka, so we can reference this as just Kafka 1992. And then tell the topic, which is JavaScript events, I think. Let's double check that. Here we have our defined our topic here. It's JavaScript events. And that's all the configuration we need. So now we can just do a simple like select star query from this data, which I always like to do to kind of see what the data looks like, make sure it looks at how I expect, that all the fields are being parsed correctly. Oh, select star from analytic events. Analytic events. And I'm going to pull up the Arroyo logs here so we can see what's going on. It's often helpful for debugging and understanding the behavior of the system. So let's find the Arroyo container. Okay, now we can start this query. You can see here what's happening. It's compiling. Starting. Cool. And now we can see these events streaming through here. You can see fields look like they're being filled in correctly. Go create a few more. Cool. So now that we have everything flowing, we can start to actually write some more interesting queries. Let's start by just counting page views. Let's see how many people are browsing different pages on our website. For this, we're going to use the window functionality of Arroyo. This allows us to compute streaming results over either sliding, tumbling, or session windows. So we're going to start by pulling back some aggregates. So let's say like the count the number of events that happen in this window. And let's say we want to group by page, so we can get the counts for each page. So we'll use the path field here. And then we're also going to pull back the window that we're going to be defining, which we'll define as a sliding window. Let's say it updates every 5 seconds and has a size of 1 minute. We'll call this window. Pull this back from our stream here, analytics events, and then we'll group by the path and the window. Oops. And now this should show us for every path how many events do we have for that path. So let's see what this gives us. Let's go browse around a little bit. And here we can see our different counts being emitted. So we have 2 visits to the home page. Now 3 visits to the home page, some visits to some other pages. So now that we have our query working, we can create our sync table where we're going to write our data so that we can eventually visualize it in Grafana. So this is also going to be a Kafka table. We'll call it metrics sync. It's going to have some fields from our output. We'll have a time column, which is a timestamp. We'll have a metric column, which will describe which query this is and will allow us to insert multiple queries into the same table. We'll have a value column, and then we'll have a tag column, which will allow us to segment the data by different fields. This is a Kafka table, so we are going to use our with clause again, copy most of this stuff from here. But this one is a sync, and we're going to use a different topic. We'll call this one metrics. And then we'll insert into our new sync table here. And to match the schema, we're going to have to actually use a subquery here. So we're going to pull out the timestamp from the end of our window. And then we're going to describe this metric, which we'll call views 1 minute. And then we have our, call this count. Our count, and then our tag is going to be path. That's what we're going to be segmenting by. And then query this from this other query. And make sure that's correct. Cool. And then just going to add a few more of these. So Arroyo constructs these queries as a graph, as you can see here, which means that we're able to have multiple queries that all read from the same sink. And we're able to just do the Kafka operations and the deserialization of the data just once and fan it out across all of these different processing pipelines. So if we want to be able to compute this at different levels of granularity, we can just do that really easily. So change that to 5 minute, let's say 15 minute. Let's make this one 1 hour. You can see here our graph now has 3 nodes coming out of the Kafka source for all these different analytics that we're producing. So now that we have our queries set up, the next thing we're going to do is start up Debezium. Debezium is a service that can take messages off of Kafka and write them to Postgres. So essentially it's a way to sync all the way from Arroyo into a Postgres or a MySQL database. These messages have to be formatted in a special way to tell Debezium how to kind of update the data, and Arroyo has built-in support for that. So we should say here that this is Debezium JSON. And then we also have to tell it to embed the message schema in the data. Which you can do with the include schema option. And this basically tells Arroyo to include the schema when it sends the data, which is a thing that is required by Debezium and Kafka Connect. So that all looks good. Let's check it. And then we can start this pipeline, which will get the data actually flowing. Cool. While that starts up, this is going to start actually processing data and sending it to our Kafka topic. We can go check that out. So let's see on our Kafka container. Kafka console consumer shop server Kafka 1992, and the topic we call this is metrics. So we should see, if we go and create some events, we should see those flowing through there. Awesome. Okay, and here you can see this format that Debezium expects. Cool. So the next thing we're going to do is create a Postgres container that's going to be the actual destination that we write our metrics to. So we're going to go back to our Docker compose file here. We're going to add a Postgres container. Going to use the just official Postgres 15 image. Expose the port. And then we're going to set up some environment variables, set the default user to Postgres, the default password to Postgres, and the default DB to Postgres. Then we'll add a health check so we can know when this is ready. And that looks good. And then we're also going to initialize our database, the one we're going to be writing to. So we'll do that with an init.sql file. Create our table metrics, and this should basically just mirror the schema that we created previously. So we can basically just copy this schema here. Oops. And that should be good. And then we'll configure our Docker Compose to add this as a volume. Okay, so now we've defined it. We're going to start the container. And it should be running. You can see NPS, yes, it's running. If we log in here, we should be able to see the table that we just created. Oh, called it metrics sync. It should be, let's just be metrics. the next step is to set up Debezium. So we're going to do that also with Docker Compose here. We're going to do that by creating another Kafka container because Kafka Connect is part of the same container. So we'll call this Debezium, and we'll use the same Kafka image that we had up here. It's going to depend on both Kafka being healthy and also on Postgres. And then we're going to override the startup script to basically install Debezium and start it up. So we're going to write kind of a series of commands here to accomplish that. First, we'll create a directory for our plugins that we're going to add and cd into it. Then we're going to go get gonna find the Debezium connector that we're going to be downloading. Search for that Debezium JDBC sync connector. Yep, here it is. So we need to download this guy. So we'll download this. And then we'll extract it. Um, 232. Cool. And then we need to download the Postgres connector. Download it here. And then extract that. Cool, okay. And then finally, we need to start Kafka Connect with our configuration. So we'll start with, yeah, it looks more or less correct. Bitnami, Kafka, bin, connect, standalone. Then we're going to put up our own configuration here. So we'll start with just, and Postgres sync.properties. Now we need to actually create these configuration files. I'm going to tell it how to run. So we need connect standalone properties. So I'm just going to copy from here. So here we have some standard configuration, and then we have to tell it how to kind of deserialize our data. So this schema's enabled business here with the JSON converter is what is able to handle the embedded JSON schemas that we configured on the Arroyo side. And then we can define the configuration for our actual Postgres sync. So this is Debezium configuration. We can see on the site how to configure this, but basically you give it a name, tell it what class we want to load, which is the JDBC connector. We're going to tell it to pick up the latest data so that we're able to kind of experiment here. We're going to tell it which topic to read from. This is metrics. And then we're going to tell it how to connect to our JDBC, that's correct. The user password Postgres. Perfect. And then we're going to set these as volumes so the container has access to it. So So we have connect standalone, properties, yep, and Postgres sync properties. Perfect. And now we can start up our Debezium connector. Compose. Let's see how it's doing here. It looks like this did not start up successfully. Let's see what's going wrong here. Okay. Oh, okay, not. Oh, okay, we missed a. Okay. So let's see our container here. Looks like it's running. Check the logs and looks good. Cool. Okay, so now we have Debezium running, and it should be syncing to our Postgres table. So we can see here again our data. Let's generate some data here. Click around on the website. Cool. And then if we pull up our Postgres database, let's log into our Postgres container here. We should actually see our data flowing into the metrics, and here we are. Awesome. Let's add a few more metrics that might be interesting to graph. For example, we might also be interested in what pages people are viewing and which pages are the most popular. So let's take a look. Let's stop this query and we'll create a new one, starting from the same template. We're reading off of the same source, but adding a couple more queries. So for this query, we're going to be looking at doing a top K calculation using a SQL window function over the page data. So what that's going to look like, first we'll kind of build this query going inside out. So we'll start by pulling our kind of window that we're computing over. So we'll pull back the count of pages and the path. And our window, which let's do this over, let's say 1 hour. And then we're basically going to be doing a SQL window function computation on top of this to find the top 10 pages. So that looks like this. So select star and row number, which is a special function that tells us the rank within this ordering. Partition by the window, order by count descending, so we get it in order of how many events there are. We'll take that as a field called row num. And then this will be pulling from this query we previously defined here. And then out of this whole query, we'll select the thing we're actually trying to return here. So we'll select the window end, select window end, call this top pages. So we'll select the window end, the path, the count, and the row num from all this, and we'll filter it by where the row num is less than or equal to 10. So give us the top 10. And then we're probably going to want a slightly different schema for this table. So we'll create a new output. So we'll have a timestamp. We'll have a page. We'll have a count, which will be int, and a rank is also an int. And this will also be a Kafka table here. So we'll, so pull in this configuration here. And we'll give this a different topic so we can write to a different table. We'll call this one top pages. And then we just have to insert into this table. Oh, let's call this pages sync. Cool. And now we have our new query here. So we'll start this. And this is going to run. Just need to update our Debezium configuration to also read off of this new top pages table and create it in Postgres. Add it to our init.sql here. So now we can create the top pages table here, and then also we can go into our Postgres container, our exec, oh, sorry, top, this should be top pages. Okay. And then should be able to restart Debezium. And then look at the logs for our Debezium container. And all looks good. Cool. And if we go back into our Postgres container, we should be able to see the top pages. Cool. Now we have our data in Postgres. Just one more step, which is visualizing it in Grafana. And so for that, we will create one more Docker Compose container. We'll run Grafana. We'll be using the official Grafana image here. Grafana latest. Be opening up its port 3000. And then send up a couple of environment variables that let us access it anonymously. And now we can just start that up. And it should be running. Looks good. Let's pull it up. Add a Postgres data source called Postgres. It's running on Postgres, and the database name is Postgres. Cool, that worked. And now we can start actually querying our data. It's very exciting. Add a query with our Postgres data source, use the code builder, and start with just a sum over our counts over all of our different rows. So we also need our time field here. we'll limit this to just one query. So we'll say, from metrics, we'll say just where metric is equal to, let's say, views 15 minute, and then to order by time, and we'll express this as a time series query. Sum of value. And then also need to group by time here. Cool. And let's shorten this a little bit. So here's our time range. And then because we also are including the pages in this data, currently we're summing over those, but we can also pull those out individually from the tag. Just need to group by the tag as well. And here we have the page views for our various pages. So let's reduce this time range a little bit. Let's turn on auto updating. Right, so we'll save this dashboard here. Turn on auto updating, and then you can see we go and let's say load a new page, one of these old blog posts here. And then in just a second, we should see that pop up here. Yep, there it is. See one page view there. Perfect. Now we can see our other data set that we created, the top pages. So this will be in the top pages table. Okay. So here we'll create a query. We'll pull out let's remind ourselves of the schema. We have time, page count, and rank. So we're gonna pull out the page and the rank from top pages, and we'll order by the rank. We'll show this as a table. As we see, we actually have a ton of things with rank 1. That's because we're outputting a new record for every timestamp. So we can fix that by filtering basically to the highest timestamp that we see. So we'll do a little subquery here where where time is equal to the max time that we have over our entire data set. And that should give us what we expect. Yep, here's our top pages. And then we can also show the count here. Perfect. And just like before, if we go and load some of these pages a few more times, we should see these counts increasing, and potentially the ordering changing here. Cool. So we're seeing this one kind of pop up the ranking. And that's it. That's real-time web analytics with Arroyo. Obviously, we could extend this in a lot of interesting ways. For example, if we included a cookie or IP data, we could do unique counts instead of total counts. Arroyo has really powerful and efficient windowed unique computations. And we could also obviously collect a ton of other metrics. Of course, our homepage doesn't get that much traffic, but this same approach will scale up to millions of requests per second to literally the largest websites on the internet. And in the next part of this tutorial, we're going to actually show you how you take this kind of prototype running locally in Docker Compose all the way to a fully productionized environment running in Kubernetes that you could run on your actual website. So that's it for now. All the files will be available in our GitHub. And if you have any questions, please email me or check out our Discord. Thanks. See you next time.